Go ahead. Okay, so now this is the idea. We have two functions, okay? So instead of having one function, we're going to have two. Yes, exactly. So we're going to find this. No, we continue to do this. It only gets more complicated. So chapter 6 is awesome. You're going to have an open note test on it. It'll still be very difficult, trust me. This next test is challenging, without a doubt. We basically just have two. So we're in a really good spot. I mean, we're going to finish this off, and we're going to have a number of days at the end where we can focus. We can take our time. We can watch movies. We can watch movies. Yes, we're done. I'll probably just have, she'll be, working on, studying for final exams. I mean, she'll have that whole business because, she's getting ready for the junior finals, which will be that last week. Senior finals I'll have to give the week before, so. But if she wants, she and I can definitely look at different integration techniques and, all sorts of stuff. Watch more movies! Oh, yeah. Well, that's what we're going to do. So Cody says go over some Calc 2 stuff. Well, you guys, after we're done with Chapter 6, that's the whole idea. I want to show you snippets of Calc 2. Not really complicated stuff, but stuff where you're like, oh, yeah, if I take it, trust me, people who haven't seen that stuff yet and jump right into Calc 2 and don't do any review, they're like, oh my gosh, I wish we could have covered this up. And it's not going to be like stressful stuff. It's going to be like, hey, we can take our time with this. We can enjoy the end of the year because we've worked hard, okay? All right? So let's do this, okay? We want to find the area bounded between two curves instead of just the area bounded between the x-axis and the curve. Now, watch here, okay? If this is f of x, this is g of x, the horizontal axis here, okay, the x-axis, is the equation y equals what? 0. So before you're always just finding the height between f of x and 0. Now it's f of x and g of x. Well, think before, in order to find the height of your rectangles, what you used to do was you used to find the height of the function. Well, now our rectangles don't go up that high. They only go up this high. So if you wanted to find the height of that rectangle, how would you do it? The height of the first rectangle is whatever f of x is. So if you want to find the height of this rectangle, what would you do? You'd subtract g of x, right? That's all you'd do. So it's super simple. Formula. This is basically section 1. Formula for the area bounded between two curves. Okay? Given g of x is less than f of x, over the interval AB, then the area between the curves is integral. So that's how I figure out infinite number of rectangles, right? That's a quick way. F of x minus g of x dx. Easy peasy. Lemon squeezy. Let's do it. Find the area bounded between y equals x squared and y equals negative x plus 4 over the interval 0 to 2. Yeah, first of all, we're going to sketch a graph because we want to get a visual. I believe that this is the most important part, everybody. I believe this is the most important part, okay? can I change it? Please. Let's go 0 to 1. Okay. Heather Niece? Hello, Heather Niece. During pre-calc? Okay, alright. Well, this is like in the future. Right now, you are in March 2015 watching this video, right? Because we watch the video next year. Which did you calc? Oh, whatever. Alright. What if a serial killer is watching our video? What? Could we be an accomplice? Alright, okay. Here we go. You got x squared. Okay, so I got a parabola, right? And then I've also got, what's negative x plus 4? What does that look like? The line with a y-intercept of 4 and a slope of negative 1. Looks like that. So I want to find the area, it says, bounded between 0 and 1. So 0 is right here. And 1 is right about there. It looks like it doesn't quite go all the way over to the intersection point. The reason why I switched it to 1 instead of 2, because I saw that there was an intersection point, the top and bottom changed. So we'll talk about that. That's for another day. That things get a little bit more difficult. So let's just make sure we understand. What's the top function? Negative x plus 4. And what's the bottom? X squared. You have to know the top and the bottom. If I would, if I go after the intersection point, then what would be the top? Yep, x squared and then negative x plus 4. So you'd have to set up two different problems then. So that's why I changed it. I thought I'd take care of that when I wrote the notes. I didn't, so my bad. So I set up the integral. We do the top function, which is negative x plus 4. And I subtract the bottom function, x squared dx. What are my bounds of integration? 0 to 1. Let's integrate. What's the antiderivative of negative x? Negative x squared over 2. Antiderivative of 4. 4x. And negative x to the third over 3. Evaluated. What am I going to get if I plug in 0? 0. Easy. So we just get negative 1/2 plus 4 minus 1/3. What's my common denominator? 6. So I got negative 3 over 6 plus 24 over 6 minus 2 over 6. So negative. Right. No, you're right. Minus 0. I should write that. Okay, there you go. 0 on the bottom. There you go. So we got negative 3 and 24 makes 21. And then negative 2 makes 19. So 19/6. Now, your calculator really can't help you out here. You can't do area between the two curves. All you can do is you can type this into your calculator, see if you did that part right. But you got to make sure you've set it up correctly. Your calculator doesn't understand this is two curves necessarily. See it? Not too difficult, is it? Okay, let's do a different problem. Yeah, let's do some harder problems. Yeah, Cody! Yeah! See that? He's got it. Alright, area bounded between the two curves. Y equals x squared plus minus 2x plus 1 and y equals 2x plus 1. What is different about this problem? There's no bounds. So what do you think the bounds are? Yes, the x values of the intersection. Very good. So what I need to do is, if you aren't given any bounds, it's referring to the boundedness of the functions. Okay, the finite. You can have, infinite bounds. I mean, we could go to infinity and stuff like that, but that's just that's a different topic. Right now, so we're just going to do this. Y equals x squared minus 2x plus 1. What does that look like? It's a parabola. And the parabola, you know, if we found the vertex, actually this factors to x minus 1 quantity squared, doesn't it? So that's a parabola that's shifted to the right how many units? 1 unit. So part of what I love about these sections is you're going to have to be able to graph a lot of stuff. Y equals 2x plus 1. What does that look like? Up 1, slope of 2. So something like that. So it's easy to see one intersection point, isn't it? Does everybody agree that this is the bounded area? Is this area going to ever be bounded again over here? How about this area up here? Is that ever going to be bounded again? No. Sometimes you can have functions where they have, you know, more than one bounded area, and you'd have to calculate each of them separately. Yeah, we'll look at those examples. Today we're just baby steps, okay? So here we go. Before I find the bounds, before I set up the integral, I should really find the bounds. And so, how do you find the intersection between two things? Set them equal to each other. They're both equal to y. Substitution. X squared minus 2x plus 1 is equal to 2x plus 1. What to do, what to do, what to do. Cancel the ones. Subtract 4x, or subtract 2x. X squared minus 4x equals 0. Now, take out an x. X times x minus 4 equals 0. My bounds are 0, 4. I have an intersection point here at 4 and here at 0. Are those x values or y values? They're x values. What if I wanted to find the y values? What would I do? Plug them in. We don't need to do that right now. So we have the integral bounded from 0 to 4. What is the top function? So I got 2x plus 1 minus the entire piece, x squared minus 2x plus 1, dx. Well, I can combine some like terms in there, can't I? Like, I'm going to have a negative x squared, so I got that. 2x minus negative 2x is positive 4x, and then 1 minus 1 is 0. So we end up with negative x squared plus 4x dx is what we want. Now we just integrate. What's the antiderivative of negative x squared? Negative x to the third over 3 plus 2x squared ends up being evaluated 0, 4. Plug in the 4 first. What's 4 to the third? So I got 64 over 3 and it's negative plus 32. Or 96 over 3, right? Minus 0, because you have 0 down there. Equals negative 64 plus 96. 32 thirds. Ain't that special. Tyler, what is your opinion of area between two curves? It's interesting. Are you just saying that to try to appease me, or is that your true feeling? It's your true feeling. Okay. Haley, what is your feeling on the issue? Beautiful. Whoa. All right. How about Queens? What do you guys think? Megan's indifferent. Julia? You don't know. She says, I have no idea what just happened. All right. Cool. All right. Rewatch the video, right? We'll get it figured out. Okay. Last example. We'll do sine cosine stuff. Find the area bounded between the curves y equals sine of x, y equals cosine of x over the interval 0 to pi over 4. At a certain spot, yes. Sure can. All right, so we're going to mark it out. What's the largest value for sine and cosine? What's the smallest value? What are the periods of sine and cosine? 2 pi. Take 2 pi. That's the period. Divide it up into 4 parts. Pi over 2. 3 pi over 2. Why 4 parts? So there's 4 quadrants where it repeats itself with positive and negative values over that given time. 2 pi stretches itself all across the 4 quadrants. So we've got it. Where does sine start? Where does sine start? 0, and it goes up to... But that looks awfully like a 3. There we go. And then comes back down right there. So here's my sine graph. You okay with that? Cosine, where does it start? 1. And then it goes down, down, up, and up. Hey, what do you know? They look like each other. They are. It's just shifted, right? Now, you guys remember that you can take a cosine graph and simply just move it over and become sine? It's different by a factor of simply pi over 2. So that's it. All right. So we are looking over the interval from 0 to pi over 4. So that happens to be actually right where they're equal to each other. We don't have to prove that. It just is. Sine of pi over 4 is equal to root of 2 over 2. Cosine of pi over 4 is equal to root of 2 over 2. Right? They both make those 45, 45, 90 triangles when we draw them. You have this business right there. Kind of an interesting shape, isn't it? So just pause for a second and realize you're going to find the exact area of that. I mean, who does that stuff? We do. Yeah. Yeah. There you go. We do. Yeah. All right, so let's do it. What's your top function? Cosine of x. What's your bottom function? Sine of x, dx. We integrate from 0 pi over 4. Very good. Okay. Just set yours on my desk. All right. Kind of a dangerous thing. All right. Antiderivative cosine. Sine. Antiderivative of negative sine. Positive cosine, right? Sine of x plus cosine of x is 1, right? No, sine squared plus cosine squared is 1. Try to get you guys to fall into a trap. You don't take the bait. All right, I already told you what sine of pi over 4 is. Remember? No. Sine of pi over 2 is 1. Root of 2 over 2. Plus, cosine of pi over 4 is... They're the same thing. Root of 2 over 2. Minus, let's plug in 0. What's the sine of 0? 1. No. Sine of 0 is 0. Plus, cosine of 0 is 1. Root of 2 over 2 plus root of 2 over 2 is 2 roots of 2 over 2, which is root of 2. Minus exact area, root of 2 minus 1. Done and done. Give you a worksheet. You got 8 problems. None of them involve trig. Just get the practice. Draw the graph. Shh, everybody, hey, you got to draw the graph. You have to draw the graphs because I know where we're going. And when we do volume, forget about this, you guys. I don't want to do just stuff like this. I then want to take that shape and I want to rotate it around the x-axis and make like a, you know, a bowl or a trumpet type shape. That's what I want to do. We're going to do that real soon here. I mean, we're going to do crazy stuff. Your brain's going to explode. It's going to be, you know, doctors everywhere. This is what we're going to do. So you got to be able to draw the graph. Draw the graph. Can't draw the graph, we get nowhere. So, all right?